So let's go forward and perhaps answer a few questions that people often ask. How does HVAC use energy and water? I mentioned before that when you break it right down, you've got fans, you've got pumps, you've got compressors, all driven by electric motors. We understand how that uses energy. It's pretty straightforward. Gas into the boilers. It's interesting, it's been said about HVAC systems that when you understand the basics, they certainly aren't rocket science, but when you start to think about how they use energy, or more importantly, how they waste energy, it all of a sudden becomes pretty complex. And that's part of the challenge around improving energy efficiency in HVAC systems. In some ways, we often get the easy things done. The hard things are actually getting right back into trying to tune these things so they work properly. From a water perspective, water is used in cooling towers obviously through evaporation, but there's a lot of water used in cooling towers in terms of drainage, in terms of keeping concentration of solids and things like that down and keeping the thing clean. Interestingly, the water consumption in a cooling tower is very much proportional to how much energy you're trying to push out of the building. So in some ways it's actually affected by energy efficiency. The more energy efficient a building is, the less energy you need to push out of the building because the less it uses, so therefore the less water you will use, which is why when you improve the energy efficiency in a building, you also improve your water consumption as well. The two actually are very hardwired in that sense. So how do HVAC systems vary? Obviously they don't all look like this. This is very much a generalisation. There are 101 different variations on the whole process. One of the important variations, I suppose, that we've seen in the last 5 or 10 years is chilled services, chilled beams. Some of you might be familiar with the term chilled beams. Council House 2, which was mentioned before, has chilled beams. These are effectively cooling or heating surfaces in a space like that actually radiate heat or cooling, but they are cooled by chilled water, they are heated by heating hot water, so the componentry is the same. You have chillers, you have boilers, you have those sorts of things as well. You still have air handling units, you still have an air distribution system, you still have all those things I mentioned before. Another option is a refrigerated system, so you take the concept of a refrigerant and write it large, if you like, and so you effectively have almost like a split system you have at home with no water. These probably aren't that common these days. How they vary in different buildings in terms of age and quality. Obviously, age and quality are a big thing. I mentioned before about amenity. There's a bit of a standard thing too, so if you've got a premium grade building, you'll have a premium grade air conditioning system capable of maintaining conditions and reliability and what have you. You've got a cheaper type of building, something that perhaps is not quite at the same standard, you'll have, again, a system which is not quite at the same standard. Why is maintenance important? Things wear out. You can see there's lots and lots of things in a HVAC system, lots and lots of things going around, lots and lots of things that are dependent upon being properly adjusted. So things wear out. Things go out of adjustment. Electronic devices drift. Seasons change. Things break. Things fail. The use in building changes. Buildings are very dynamic places in terms of their needs. On the other side, air conditioning systems are very resilient systems, the way they're designed. You can have a lot of things go wrong with an air conditioning system which might significantly compromise their age. Things might wear out much quicker. You might use a lot more energy. You can have a lot of things go wrong and you'll never notice because they'll still maintain conditions. It'll still be 21 degrees inside, but you're using twice as much energy, you'll never know. Or you're wearing out your chiller at twice the rate you should be, but you'll never know just by simply the fact that thing's still doing its job. Very, very resilient. There might not be enough outside air coming in. It's a long time before people will start talking about it being a bit stuffy. So, but you're outside of regulations. So, some very interesting aspects around air conditioning. They're very resilient systems. How do I get to know my HVAC system? Michelle suggested you go downstairs and patch a chiller. I'd make a better suggestion. Get to know your maintenance contractor. You'll find technical people are only too happy to explain things to you. Get to know your maintenance contractor. With some of the insights that we're talking about today and perhaps a little bit more research, have an understanding of these things and go and talk to your maintenance contractor. There's no such thing as a dumb question, only dumb answers. And seek to understand. It's not complex at all. There are a lot of references out there. ERA has an online course called Air Conditioning 101, which is very much this multiplied out. A lot more insight, a lot more exercises to do, even the history of HVAC and what have you. My organisation, we put all our non-technical people through the course. There's no good working through a building services air conditioning specialist company if you don't know what we do. And it's a very useful thing. So go to the Aero website and have a look at that. There are also a range of documents that are available there. Some are very, very technical. If you wanted to go to the next level in terms of understanding, that's not a bad one, which is Introduction to HVAC and R. You probably, as a non-technical person, won't understand half of it, nor do you need to, but clearly with some basic understanding it'll be a useful thing to do. So there's lots of references out there that you can go and have a look at. Carolyn's just sitting down there waving her arm, so if you wanted to talk to her afterwards about what Aero can do around all that, that would be great too.